Okay, good afternoon. I wish to thank the organizers for inviting me here. It's a quite special opportunity for me because actually I have a background in theoretical physics, then I moved to bioinformatics, and I spent most of my research life in bioinformatics. But actually in quite recent time, which means I would say 4 or 5 years ago, I moved into this field, which is cognitive psychology, educational psychology, and learning processes. So this is the first time I talk about this new, for me, research interest. So I want to say another thing. Actually, I'm not from Sapienza University. I worked about 10 years at Sapienza University. I'm still based there, but I work for the National Research Council of Italy, and my institution is actually based in Sapienza University. So the idea and concepts that I will tell you today about are the outcomes of a collaboration with Rochelle Trachtenberg at Georgetown University and Jessica Lindvall from Sweden and Elixir Sweden and Terry Atwood from the University of Manchester. So the four of us developed, or we're still developing, but we are almost done, a tool that is called the Master Rubric for Bioinformatics. And it is a tool for curriculum development and assessment that can be also used by students and teachers to self-assess or to monitor teaching learning. And unfortunately today I don't have the time to talk about this tool because it is a quite complex construct. But I will talk about ideas from cognitive psychology that underpin this tool. So while preparing this talk, I was thinking, what's the point? What's the point for a teacher? And the point is excellence in training and in teaching. At least that's what I have in mind. But if you Google excellence in teaching, you end up with a large number of example awards for teaching excellence. So what is an excellent teacher? What really is excellence in teaching? I found this sort of definition that I liked quite a lot. And I want to point out the lifelong learning aspect, the fact that an excellent teacher is able to inspire lifelong learning. But the big problem is that there are too many teachers who don't inspire anything, and too many teachers who don't reflect on what their teaching should look like in order to be at least similar to excellence, okay? To be a good proxy to excellence. So we had a lot of discussions and a lot of reflections with Rochelle and Jessica and Terry, and we ended up with these three main features that excellent teaching should produce. And one is the acquisition of high-order thinking skills. So basically, usually we teach bioinformatics skills, programming skills, or whatever you teach. But the point is that we don't only want our students to be able to run programs, for example, or just simply let a program go. What we really want is that our students become able to integrate what we teach them in the general picture, and then they can critically think about what we teach them, about the tool they learn. So second thing is ability to integrate the new skills into repertoire, which means in the general picture, and this is especially important for a multidisciplinary field like bioinformatics. And the third point is long-term retention and ability to build on the teaching. And all these can be summarized in the idea that excellent teaching should produce sustainable learning. So what we mean by sustainable learning? So basically, we can think about sustainable learning as lifelong learning. And this is something that an increasing number of institutions and disciplines have started to include in their mission statement or objectives. Another definition that is in the title of my talk is the learning enterprise. And that's why this definition is important. It's important because it is strictly connected to lifelong learning. And the keywords in this slide are the fact that the learning enterprise is a joint effort by the instructor and the teacher. And this is one point. Another point is that it has to do with the developmental trajectory. So it's something, so the idea is that basically when we think about our teaching, we focus on our course, on the objectives of our course. And we don't think very often about how our course and our objectives integrate in the whole picture of our entire program of study. Okay, so that's the idea of the developmental trajectory. There is a postscriptum here. Actually, this is a quite important thing, but still it's a, let's say, a side comment that is developing expertise and documenting that development, which means also assessing that development, is fundamentally different from doing well on exams. Okay, maybe we're not aware of this, but we know, all of us know this. Okay, with these premises, now I would like to move to the second part of my talk and talk a bit about what are the lessons learned from cognitive psychology. Cognitive psychology in a very, simple way can be defined as the study of mental processes. So the idea is that what should we know about mental processes and learning processes in order to make use of these concepts and achieve excellence in teaching. So far I mentioned excellence in teaching and what is desirable in excellent teaching. And I mentioned lifelong or sustainable learning, and I gave you a definition of the learning enterprise and also what cognitive psychology is. And now the thing that I would like to talk about is metacognition, formative assessment, and Bloom's taxonomy in relation to what I've introduced so far. So, metacognition. That's a pretty good definition of metacognition, the process of reflecting on and directing one's own thinking. So basically it's thinking about our own thinking. So this definition actually don't say anything about the role of a teacher in developing metacognitions in our students. And another thing that is not explicit in this definition is the fact that metacognition can be learned and can be improved. So the whole idea here is that if we were able to develop metacognition in our students, we would be in the good way to go towards excellence in teaching. This is one of the 7 principles that are listed and discussed in this wonderful book How Learning Works from Ambrose et al. And I think that every teacher on this planet should read this book. It's about 7 principles of learning, and this is the 7th one, and this is about metacognition. And this, here, there is a description of what are the metacognitive skills that a student should develop in order to become a lifelong learner. So look at the keywords: to assess the demands of the task, to evaluate their own knowledge and skills, plan, monitor, adjust their strategies as needed. So now the point for us as teachers is that we think that students are naturally able to do this. They aren't. They aren't. And we are. I mean, if our aim is excellence in teaching, our aim is to teach them all these skills. So the Ambrose book also provides general strategies to promote metacognition. So basically 2 general strategies. One is model your own metacognition as a teacher. So basically model your own metacognition means that you make explicit your own metacognition processes to your students. And the second general strategy is scaffold students in their metacognitive process, which means scaffolding refers to the process of supporting your students in the early stages of learning, and then start removing this support as they become more expert during the process of learning. The point that in order to be able to model your own metacognition and to scaffold your students in their metacognitive processes, you need to be aware of the fact of your own metacognitive processes. So basically, the thing is that in most of the cases, faculty or teachers themselves, they need instruction in and practice with metacognition, which is not something trivial. Another thing for which metacognition is really needed is formative assessment. So I think that everybody here knows what formative assessment is, but still basically is the process of providing bidirectional feedback all the time during your teaching, during the learning. And I say bidirectional because the teacher provides feedback to the students provide feedback about the teaching to the teacher, and this is really a fantastic way to teach and a fantastic way to learn. So the point here about formative assessment and metacognition is that formative assessment, we use a lot of formative assessment, or hopefully we use a lot of formative assessment to teach bioinformatics skills or any kind of other skills, but we can use formative assessment also to develop metacognition. So the idea is that formative assessment around metacognition can be integrated into teaching of content. So it can be put on the top of the teaching of content. So the idea is that in this case, the feedback becomes feedback on thinking and not only on knowledge. So I want to reinforce the idea is that faculty might need to develop metacognition for and in themselves. Okay. Bloom's taxonomy. It has been mentioned several times today, and so I'm not going to describe it in details. But one thing that I want to stress is that this structure is hierarchical, which means that, okay, usually everybody puts the lower levels at the bottom of the taxonomy, just because these levels are absolutely needed to build on and achieve a higher level. One important thing is that I put the dashed squares around the top levels, analyze, create, evaluate, just because these are the levels of critical thinking. So, but the point here is that usually, and that's the fact that the taxonomy is hierarchical, is that you have to move from level 1 to level 2 to level 3, etc. In other words, you have to build the lower levels if you want to move to critical thinking. What are the lessons from Bloom? So if you want to develop the ability to evaluate, for example, to evaluate a bioinformatic tool or method or results of our research, you must first develop the less complex abilities. So that's the idea. But if your instruction does not go beyond level 4, you remember level 4 is at least analyze or create and evaluate, basically your students won't be able to move on, won't be able to deploy the tool that you taught them in novel problems. The idea is that science or interesting things happen at levels 4, 5, 6. Basically, if you want that your teaching is going to be used to advance in the field, you have to be able to bring your students from whatever low level to the to upper levels. So the message here is that your instruction should be designed with higher level Bloom's functioning in mind. So I'm not going. I was thinking about talking about MESIC, and but I think that it's going to be too much because it needs a bit of introduction. So I will move to the conclusions. The lesson learned from cognitive psychology that we have very briefly seen today can be used in many aspects of teaching, and at a quite simple level that can be used in the design and in the assessment of instruction. I think that we all of those who do teach do this. Then can be used also to develop our own metacognition skills, or since we are teachers, we are supposed to already have metacognition skills. So let's say that we can use these lessons to develop awareness of our own metacognition skills. That's quite difficult, but still, I mean, it's absolutely doable. Next thing, that can be used in helping students develop metacognition skills. And this is very difficult. This is something that is very difficult. This is something for which perhaps we need training as teachers. And then can be used to help students achieve sustainable learning. This is extremely difficult. And also to support the engagement in the learning enterprise, and hopefully at the end of the whole story to achieve excellence in teaching. And this is again something that is extremely difficult. I don't want to say impossible, of course. So, okay, in thanking you, I want to really thank Rochelle, Jessica, and Terry. Rochelle has been and still is my mentor. She is a cognitive psychologist. And Jessica and Terry, they are bioinformaticians. And the three of them, they have really changed my life. I can say this. And not only my research life, they are also friends, and we meet every Thursday for 4 hours on Skype. So they have also reshaped my week. Okay, thank you for your attention.
We're actually running a couple minutes late, but if there's one quick question.
Yeah, I was wondering if you could elaborate on the issue of formative assessments. What are some concrete examples of formative assessments you find particularly useful for bioinformatics education?
Yeah, okay. We have a couple of hours. Okay, so example. So basically, formative assessment can come in many different forms. So this could be just, for example, questioning, asking questions, and or running diagnostic questionnaires. So that's another way you can. But flipped classrooms, working in groups, peer instruction. These are all, these are all ways to promote formative assessment. Basically, you collect information on how learning is going and on how your teaching is going. And you adjust. When you realize that learning is not going the right way, you adjust. Or when you realize that your teaching is not going in the right way, you adjust. So basically, that's the idea.